Hello, it's David. A long time ago now, I recorded a video where I built this crude homemade adapter for a hard drive emulator for my ST. Now this is a project called ACSI to STM, and I never got around to building a proper motherboard for it because frankly this has done a wonderful job and I've just been lazy. This is also based on old open source version of this project, and there's a new updated version that's available commercially which seems very popular, so it seemed pointless for me to pursue this any further. Basically what this does is this interfaces the Atari's ACSI port here via a blue pill, which is an STM32 dev board, I believe, to a SD card. Anyway, this has worked perfectly well for me, and this is what I've been using as my daily driver, but it is a bit messy. And on the Exxos forum, a new user signed up stating they'd got themselves into retro and had built one of these, an ACSI hard disk emulator based on a Raspberry Pi Pico. Now the Raspberry Pi Pico is quite unique at the moment in that it's very easy to obtain. It's quite available. Even these things here are rather more expensive than a Raspberry Pi Pico board. So I thought I'd help him out and design a dedicated board based on his schematic. This is the Pi ST HD emulator by Steve Bradford. It's my board design, but these are his schematics, and a Raspberry Pi is mounted on the reverse here. A Raspberry Pi Pico, I should say, is mounted on the reverse here, and this can be flush mounted. Now, Steve originally spec'd some through-hole line buffers, and he was in the process of changing them. We weren't sure how that was going to work out, so I actually provided footprints for 2 sets of line buffers, which is why you see 4 chips at the bottom here. 2 are the TXB0108s that he specified, and 2 are my usual SN3T 3245s, which I use on most of my other projects, and I'm pretty confident will work. So it's a dual footprint board depending on what is available. Now, I built this board, or designed this board, back in December of last year, but since then I've had a baby, and time has unfortunately been very, very tight. Now, in the meantime, Steve has had a change of heart, and he's actually taken this project back closed source and is developing a commercial version along with Exxos, soon to be available in the Exxos store. So this is really a for information build based on the state-of-the-art as it was back in December. So my boards have arrived, and I've got some of my materials. This is the push-pull SD connector. We've got the line buffers. We've got the we can have 2 different types of line buffers, as I explained in the design. This is the original type, the what's it called? It's the TXB0108. Apparently there's been some issues with those, so that might not work. The other one is my standard SN3245s, which I can't lay hands on at the moment, so I'll be building this one first, but I'll build one of each and we'll see how it goes. This is a line driver. It goes up on here. That's a HCT 125, and I've actually got a bug on here, which means I thought they were inverted. They're non-inverting, so my my SN 3T 3245s, they actually would need a firmware change in order to work. We've got a nice load of DB25 connectors to fit on the bottom there, to be cut down, and obviously there's a lot of birdseed on here, which is probably where I'll start, to be honest. So actually no, I won't. I think I'll start with the chips, because if you mess the chips up, then you give up and you come back, you haven't wasted all your time on the birdseed. So let's get on with the chips and see how we go. Now, would you believe it? PCBWay have just turned 9 years old. They've been sponsoring my channel for the last year, which means that they've been sponsoring me for 1/9 of their life. Quite amazing when you think about it. Now, as you'd expect from a company called PCBWay, PCBs are their stock in trade, and they really are top-notch in that regard. They've produced every one of the PCBs that I've featured on my channel in the last 12 months. But as I've been telling you over the last year, that's really not all they do anymore. They can offer you CNC machining, 3D printing, sheet metal fabrication, and injection molding, all right here from the website. If soldering's not your thing, they can even assemble your PCBs for you. Normally get a man in to do that. Do please have a look at their website. They are really a one-stop shop for all your maker needs, and I do wish them a very happy 9th birthday. No load on the back, just the pin headers, so don't need to worry about that side for now. And I think, I'm just trying to think which way I'll do. I think I'll do the SD card. Maybe I'll just do one SD card to start with, in case it doesn't work. Oh, I'm going to have a go on SD0 here, I think. Just because the capacitors and the other little passives are very close to that, and it would be awkward to solder them first. Now this one's a little bit, it's going to be very difficult to capture on camera, this, because I'm going to be soldering it backwards. But you kind of have to get in underneath the component. You see the pins are actually hidden away. So you have to kind of get in underneath the component to get it to solder. The pads on the side there look very small. Oh well, let's give this a go. Let's introduce a bit of flux there. Okay, that looks better. My K-tip may actually be too large for this. Could have been a mistake. Well, I've definitely done the capacitor pads. I think that may be okay. Very difficult to see what's going on there. I think that might be alright. Okay, so that's pretty terrible, but I think that'll work. We've got, actually that's still loose. We've got a diode, resistor, capacitor, and then the rest are mostly passives. Pin headers on this side, and the DB25 probably last. So I think I'm just going to get on with the passives now, and I should probably take that off camera. Okay, so a bit of scrubbing later on, complete the soldering, a bit of scrubbing later on, and this is the result. So the Raspberry Pi Pico, you can solder it directly on here. These pads are large enough for that. It is intended for that. It is a flat surface for that. But I've put the standoffs on because obviously we're dealing with a first build here. I managed to spill a load of 1 nanofarad capacitors everywhere, so I soldered on that 1 nanofarad capacitor there before I put the rest in the bin, so as not to waste it. A little bit annoyed about how drunk my SD card holder is there, but fingers crossed that won't matter. And as I say, this is the board that has taken the 0108 route. I have found my big box of 3T 3245s, which is the level shifter that I use on DFB1, DSTB1, and all my other various little level shifting projects there. So my next build will use that one. There will have to be a slight firmware change to invert some logic, but otherwise I'm more confident in that one working than this one. But I want to give this a go anyway. So the way the DB25 works here is that only the first, I think, 19 pins are used, and then we've got spareys at the end here in order for it to fit on the back of the STE, which you've seen me done before with my other hard drive adapter. I don't have it here actually to show you, but you've seen me do it before. So what I need to do is to trim off these pins and and the end of the casing here, so that it will fit on in the back of the STE. So I'm going to have or the ST. So I'm going to have a go at that. So 1, 2, 3, 4, 5 pins on the top. 1, 2, 3, 4, 5 pins on the bottom. So, who noticed my deliberate mistake? Yes? Well, congratulations if you did. If you didn't, well, I'm glad I caught you out, because now I've taught you a lesson. Yeah, no, okay, not that deliberate. This damned DB25 that I spent an age hacking through with my side cutters, I said, yes, we removed 5 from the top and 5 from the bottom. Well, we're trying to make a DB19, and taking 10 pins off a DB25 does not make a DB19. No, it's supposed to be 3 from the top and 3 from the bottom, and I've just chopped away a load of pins that I need. So yeah, I'm going to see if I can get this off with the desoldering station, and we'll have to have another go at that. I might take a different approach next time. I might try and snip everything off and see whether just the inner comes out and whether that's solderable. But yes, whoops, never mind. So here we go. Let's see. Never much good at desoldering. See if I can do it without ruining the board. So that's the first pass, and yeah, I don't see much much movement. The wiggling, I think, is mostly the shell. So let's do a bit of wiggle, wiggle, wiggle down the rows with the pliers. I don't seem to do much either. I heard a couple of little clicks there, so some. Not seeing a lot of movement. So one thing is to try and attack it from underneath so that the solder runs downhill. Might just do a quick round of that. It's not very photogenic though, I'm afraid. Yeah, that's not working for me. So okay, I think it might be time for plan B, and I think it's the hot air. So I'm going to whack the hot air up to, let's say, about 380. I'm going to try and do this in such a way that I can maybe wiggle it. We'll get the clips here on the pardon me. We'll get the clips on the DB25, and I'll try and lift the board away from it as we heat it. We'll see if that has any better success rate. I don't hold out to the huge amount of hope, to be honest. I'll put some of this liquid flux on, because I know my flux paste just basically turns. I know this will boil away quite quickly, but I can't see that it would hurt to try. My flux paste just seems to turn into caramelization, basically. Okay, we'll give this a try. Well, I felt a little bit of movement there. Something clicked. Yeah, there's a little bit of movement at one end. Yep, that end's going. There we go. Okay, so the combination technique actually worked fairly well, and I don't see any obvious damage there. Fortunately, I have enough of these DB25s to experiment with. So what I was thinking to do this time is actually just try and cut the shell away, because we saw how easily this parted in the middle. And I wonder if by cutting the ends off, the entire lot will just fall off. I can solder the central block and then just cut the pins away that
that I don't want to use, or not even solder the pins that I don't need. So this could go even more poorly wrong, but I'm going to just try cutting through these end pieces initially and see how far we can get. This is obviously double thickness here, so this may be very, very difficult indeed. That looks like it's just coming apart at that seam there. Aha! Well, well. Okay, how about that then? So finger over the end to stop them flying everywhere. 1, 2, 3, 4, 5, 6. There is a DB19. Second time's the charm.
Okay, so it's time to test out our card that we built there. There's a couple of things I needed to do in order to get the project as published to compile under my Debian stable version here. Very simple things. Firstly, the CMake minimum required version was set to 3.2. Changed it to 3.13 because that's what I have. And there was an additional line in here about policy, which I have removed. That was stopping it building for me. It doesn't seem to affect the build, so I've removed that. The second thing, there's been a change in the SDK since it was published. You need to add an include Pico time.h to the SD card.h to get it to compile. And third thing, not necessary but helpful, I think, is to increase this sleep milliseconds call in the muinit.c. Just to give my terminal program enough time to connect. So it's set for 3 seconds, not enough for my terminal program, so I've increased it. I'm using the Arduino terminal here, so I've increased that to 5 seconds. So having done that, standard CMake stuff, you make a build directory, you cd into that, you call CMake ... which means the directory you've just left. That will provide you with a make file, and you just then call make. Away it goes, doing its stuff. This is, of course, assuming that you've installed all the Pico SDK according to the instructions, and you've cloned your repository here. Everything's gone well. You've been able to build the test blinky, this kind of thing. And there we go. Building has done, and we are left with a UF2 file. This is the crucial file that we need to flash on to our Pico. Okay, so I've just brought the file manager into picture here so we can see what's going on. Now, the technique is, what you have to do is there's a button on the Pico for the bootloader. You press and hold the button, then you plug in the Pico. Should be able to release it then. And after a couple of seconds, we should see a virtual file system appear on our machine. There we go. Raspberry Pi RP2 appears there. I click that to mount it, and you just get two instruction files in there. And all we have to do is to copy our UF2 file. Copy star UF2 into that directory. So media. There we go. Once that's copied in, there it is. It'll automatically unmount, and at this point, the system will reboot. So we'll go to our terminal, and there we are. We can see already we've got output on the screen. In this case, it's detected the SD card that I've put in, which is my normal STE SD card. This is the one with the ICD drivers on it. There we go. So we've got ourselves a 16 meg card, and we've got 4 partitions: big gem, extended gem, Linux. So there we go. That looks to have started up okay. So let's fire up the ST and see what we get. Okay, the ST's on, but I'm holding reset, and you can see that it's picked up the reset here. So that's good. Let's release reset. There we go, and we'll wait for something to happen. Okay, there's our ST screen. Ah, look, and you can see activity already on the bus, so it's picked things up. Okay, it thinks we've got a 16GB card. Well, that went very well. So this is just AHDI, which I've got on the floppy disk here. So that looked like that picked that up. So let's install devices. CD. Okay, I wouldn't expect it to be able to read D because I think that was a 2GB partition, and ENF Reliance partition, so it's not picked those up. But can we read drive C? We can read drive C. Let's have a look. Ah, okay. So it's almost working. Yeah. But it's all corrupted. Okay. Interesting, I can get the directory. And yep, those are definitely, files that I've put there. Yeah, let's pick that one up. And I can see the activity scrolling up here. There is a hard disk driver installed there, which doesn't seem to be booting either. So that's a bit of a shame. But it's not, to be honest, unexpected. So Steve warned me around Christmas last year when he built his prototype that the chips that he had specified for the level conversion. So obviously we've got a 5 volt port here that goes into the ST, whereas the Pi Pico is all 3.3 volts. So we need to do level translation between the 5 and the 3.3, otherwise things go pop. These chips, which I think are the TXB 0108s, he said that he had terrible trouble with these and that they just weren't quick enough for the task at hand. So we kind of saw, AHDI picked up all the information actually perfectly well. So we saw activity there, but unfortunately he did say he wasn't expecting that to work. So that's why I've actually got a dual footprint. Well, that's not why, but I do have a dual footprint on here to take my Texas Instrument 3T 245s, which are my normal level shifting chip. So I can build up another one of these and try those instead. So I'm not going to waste too much time on this. Suffice to say, I wasn't expecting that to work first time, but it actually got a lot further than I was expecting. We could recognize the partitions and see the contents of the root directory of C at the very least. One thing I'll mention, unfortunately, chip detect did not work. Chip detect is buried under on this SD card reader holder. It's actually underneath here, and I don't think there's any way to solder it without reflow. So what I've done, that's that trace that comes down there, and that's ground. So I've just bridged those two so that it thinks the card is permanently inserted, and it just means that you can't hot swap this. I would need to spec a better SD card holder for the next revision. Okay, never mind. On to the next build. Okay, so I'd had a fair bit of practice with that first build, so the second one didn't take very long at all, and these have got my usual 7.4 3T 3245s installed, so I'm fairly confident that these ones will work better. But when I first plugged it in and ran the tests, I couldn't pick up the SD card at all. This is the error that I was receiving. A little bit of inspection later, and there we go. Bit of a solder bridge. Bit too complacent. Still, easy fix. So let's get back on with it. Okay, so here we go. This is the new board built up. We've got the two 3245s in place here, and we've got our solder blob here on the card detect as before. It's plugged in. The serial connector The serial console is showing that it's recognized the 4 partitions again, the same as previously. So I'm just going to plug this in now. And we will throw the switch and see how we do. Okay, power's on. Don't see any activity there. What's on the screen? Okay, we've got the Atari logos up. I've got AHDI in the drive. Oh, okay. It booted. Oh, great! It booted the installed hard disk driver. It's got the ICD hard disk drivers installed there. What if we let's remove all of this? So it's obviously read the desktop inf because we've got a screen up. We've got things pre-installed. There we go. It's recognised all the drives and it's obviously loaded the disk driver. So this looks like it's working. So we couldn't read our new desk inf, could we, before? Let's have a read of new desk inf now. There we go. Look at that. Perfect. Ah, well, that's excellent. Well, let's boot into Mint then and see how that looks. I'll just all we have to do is to rename this PRX or PRG, and we should okay. No. Okay, well, I'll tell you what, let's put in a freshly formatted SD card and we'll see how that goes. Okay, so I've got a freshly Atari partitioned SD card here. This has got 3 partitions on it, a 200, 500 and 1000 megabyte partition, just to see what's going on, and a copy of the HD driver things on there because that's what I used to partition it with. I'm going to put AHDI on the floppy emulator again. HDI 6, there we go. Right, so we're powering up. We can watch for activity down here. There should be a flash as it tries to auto boot, and there obviously is nothing to auto boot this time. I didn't see any flash. Oh, there it is. Yep, there was a flash. Okay, so that won't detect anything. Now that I can hear that that's loading from, there we go. There we go, 8 GB SD0. Yes, it's correctly picked that up. So let's install devices. There we go. And this should have, yeah, just the HD util that I installed on there. That one, yep, that works fine. That's readable. And this one is a just shy of 1 GB device. TOS 2.06, I think that should work. No, maybe that doesn't. That seems to have... Maybe 1 GB doesn't work with TOS 2.06. Maybe that's only with TOS 4. Let's reboot that and we'll try again. So we'll stick to drive C. Okay, and there we go. 8 GB detected. Install devices, drive C. There we go. Can we read the program? It might need, yeah, we can read the program. Okay, cancel. Don't care about running it. Let's try and copy a file then from drive A onto drive C. We'll just copy this README file. No. Okay, that's the same problem. And we'll create a directory then. No, okay, all right, so we can't write, so there's a problem writing. Okay, well, I'll tell you what it might be. Okay, so when I designed this dual footprint board, I made a mistake. The TXB 0108s that are used, that were initially specified here, have a bus enable line, and the bus enable is active high. Now, my preferred chips here, which obviously seem to be working for reading, are the Texas Instruments 3T3245s, level shifting. They have a buffer enable pin, but it's active low. So what I did was I mistakenly believed that this chip here, I can't remember the name of it, this was inverting output. So I routed my bus enable lines through this chip in the mistaken belief that it would enable me to use the same control signal for both these two chips. I realized after I'd ordered the board that no, it is non-inverting, so I actually have had to change the firmware to assert that line oppositely. Now that seems to have worked in so much as we can read data happily. That looks good. Even boot the hard disk driver, but not for writing. So perhaps I've missed somewhere in the firmware where that chip is where that line is asserted, and I need to invert that a bit more. So that's what I'm going to go away and have a look at now. Okay, so it's a week later, and I've had a chat with Steve on the forums, and he's suggested I try his latest firmware. Now, this one's not an open source firmware, but he suggested I give it a go because with the buffers that he now uses, they are also active low. So he's done that conversion himself. So I've just installed that, flashed it, tried with both my SD cards again, and I get exactly the same. So that suggests that it's possibly not a firmware problem, but maybe I've made a mistake in my hardware somewhere. Is it possible that the read-write line, for example, is not getting correctly passed through? I think this might need to be drawn to a close here. We've obviously made a lot of advances. You can see how the board is meant to work. I need to go away with the magnifying glass and start buzzing out some of these lines and make sure everything works. One thing I could do, I was thinking, was actually to cut the buffer enable chip lines and actually just hardwire it to ground, because I don't think there's actually any reason why they can't be permanently connected. But this symptom of it working or behaving the same way with the new firmware would suggest to me that it's not a problem with my SD card. I've tried both. It's not a problem with the partitions. There's different partitions on there. It's not a problem with the firmware. So it only really leaves the hardware here. So I think I will. I'll maybe be looking into that next. Thank you for watching. I'll let you know how this gets on, and hopefully we can get this working in part 2. Generally, the version of this available on the Exxos store is going to be more modern firmware. It's going to be better supported. It's not very expensive at all. It's in a different form factor, but I would really suggest, unless you have a particular desire to build a board and write your own, that you go and have a look at that, and there will be a link in the description down below. Anyway, that's all for now. Thanks for watching. Give me a big thumbs up. Cheers. See you next time.